Did you go through it? Any doubt in whatever we have completed? The algorithm, how to write the algorithm, pseudocode, the flowchart, and have you tried the problems that I have given us the classwork in LMS? Did you check the forum, discussion forum? So if not, please check the discussion forum. I have given some 4 patterns to work with. So you can just try it. You have to write the pseudocode. Okay, Sandeep, like where you're stuck, you can just tell me, like you can just message me through the WhatsApp. Yeah, I hope everyone knows my WhatsApp number. So you can just take a, like wherever you're working, like in your system or in on wherever you're writing the pseudocode, just take a screenshot and just send it to me and tell where you're stuck. Okay. Well, work on it. Then we have even some classworks here on the slide. You can try that one as well. So printing the pattern like this. Okay, this is again the pattern printing. You can try that. So all these are nothing but for the practice purpose. Okay, so how to build the logic? So this is the way to build the logic. Okay, so logic building, without the logic building, we can't do the programming. Okay, so which means that is the base. Without having the logic, what to implement? Okay, so this is how we have to practice. You should practice the how to print this one. Okay, so before going to the actual program, try to get it. Okay, then check with your logic whether it's getting properly or not, whether you are getting it properly or not. So in this pattern, you can see here is a pyramid. Okay, inside that is a pyramid of these underscores. Okay, so that's nothing but the underscores used. So 1, 2, 3, 4, then 2 underscores, then only like in the first line there is no underscore. From the second line, okay, you can see 2. This for third line 4, then this fourth line 6. Like that it goes on. So everywhere. So overall, what it is? This is a square. So in square, that's a pyramid, or you can view it as uh, like this is an inverted triangle. Okay, 1, 2, 3, 4, 5. Then 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, like that. The first half is an inverted triangle, then a pyramid, then another inverted triangle. Okay, so you have to try for that. So how we tried for the S-trace pattern, okay, like this one inverted triangle, along with that the pyramid. So along with that one another inverted triangle is coming in that pattern. So try it in case here it was the spaces at the start. In this one, it's nothing but instead of spaces, it's nothing but the digits getting printed. Okay, and in case of stars, it's the underscores getting printed. So try it. It's a similar one with one more inverted triangle. Okay, then you can even find this like we have already done the largest of 3 numbers. If so, you can easily do the largest of 2 numbers. The algorithm, which means you can go with the pseudocode or the flowchart. Then the largest member of an array. To know this, you should know what's an array. So as of now, you don't know what's an array, so you can keep this as pending. Then count the number of vowels. Okay, so you can take some input. Okay, so reading the input, maybe you don't know as of now. Okay, so anyways, consider the like you have a set of characters with you. From that, how to find the vowels. So you have to just build a logic there. Then reading the string, okay, or the group of characters. That all things we have to learn later. Then count the number of occurrences of each vowel. So again, that similar one. Then find the sum of n natural numbers. This we have already done in our class. Then convert a number from base 10 to base n. So this is like converting from base 10 to base n. That is the number system conversion. To know this, you should know the number system. Okay. So we will start with the number system. So we have to keep this one as pending. So conversion of a number. Okay, so how to do that? If to do that, first you should know what is the base 10 number system. Base n, it can be in place of n, it can be something like 2, 8 and all. So we will see what it is. Okay, so before that we have another chapter. So this particular chapter is done. The problem solving is done. And my question is, do you have any doubt? Did you get an idea how to solve the problem? So how to write the algorithm? You can go with the natural language or the pseudocode or the flowchart. So are you clear with all these three? Yes or no? Do you have any questions? Do you have any doubt? Why? I can see a big silence here. What? Why? What happened? Are you not able to follow? One for example with pseudocode. Okay. Steps of problem solving. Okay. So Ankit, like which one should I give? Okay, I'll just take one simple problem. So in fact that's like it was a classwork only, a previous one. So that's to write the pseudocode. Pattern one. Pattern one. Okay, let me see. Any simple pattern. Okay, let it be like. So So here I'll go with one, not two, three. Mm, I don't know, Sandeep. It's not like it's not properly coming here, Sandeep. That pattern. Ninth one. Okay, Ranjit, we'll do that. We'll just check how it's printing. So I'll just go with this. And it's your turn. Can you tell how this is going to get printed? Again, this is right triangle. Okay. So whichever pattern it is, you have to just do it like dividing it into rows and columns. Okay. Dividing that pattern into rows and columns. So here, if I divide that into rows and columns, I can say there are 4 rows. Okay. And 4 columns also. Okay. 4 rows, 4 columns. Now, can you tell how to write this one? How to get this pattern? Any idea? So right triangle star pattern we have already done. If that's clear, you can answer this one. Increment by 1. Okay, so it's like we have to get the idea how many times or how many rows should be there. So here also I'm going to take the number of rows from the as the input from the user. Okay, after that, in the first row, I always see in the first row how many times it's printing, how many columns are there in total. Okay, in the first row, out of the 4 columns, I'm printing only for the first column. In the second row, Out of the 4 columns in total, I'm printing for only the first 2. So first row, one time printing, second row, 2 times printing, third row, 3 times, fourth row, 4 times. Like that it goes. Okay, so every time what I'm printing, whatever is the previous value, that plus 1, that is what I'm printing. Okay, starting from 1, what I'm printing is 1. Then the next time when I'm printing something, that is like increment to the previous one. Again, printing the next one. Okay, so it's like there should be a variable. Always I have to, whenever it's printing, increment should happen. Okay, so the printing the value, so I should have a variable. So I'll just take the variable, initialize the initialize. Initialize count some variable, count as 0. Okay, then what should I do? Okay, so count as 1 I can give. Okay, count as 1. Then what should I do? So to access the row, I should have a loop. So that loop, in that loop, from where to where the row value will go? From 1 to n value, the row value. Okay, or I'll just keep this as n. Okay, so 1 to n it's going. So I can say I will go from 1 to n. And the j is like every time when the loop runs. Okay, so according to the one row value, loop j for the column. Okay, each will go from where to where till the row value, whatever is the row value, till there only it's going to print. Yes, correct. So it will go from 1 to I value. So first time when the I value is 1, it's going to print only one time. Second time I value will be in the second row, I value will be 2. So it's going to, this loop is going to run for 2 times and it's going to print the values 2 times. So every time when the loop runs, what we are going to print? We have to print the count value. Print count. After that, do we have to do something? We have to increase the count value. Count equals count plus 1. Okay. After that, what it is? So first time printing 1, that is the count value initially. So printing 1. After that, incrementing the count value to 2. Then coming here, printing the new line. So control comes here. Okay. Now what it is? Again, the I value is incremented. I value will be changing from 1 to 2. Okay. So there what it is, according to that row value, okay, the loop, this loop will run. So 1 to I value is 2. So for the value 1, for the j value 1 and for the j value 2, this loop will run and it will print the count. So it will print the count value, it's 2. After that it will be incremented. Again coming here, printing the j value will be incremented to 2. So what it is, it will print the count value again, it will print 3, again coming here, incrementing the value to 4. Like that it goes on till where? Till the loop value or the I value reaches n. Okay, whatever is the n value. N is nothing but the number of rows. So like that it goes on. Is that clear? Is that clear for you? Okay, Ankit. So who had the doubt in this one? How this will work? So I told here to print this directly, we can't print this star first. Okay, so to print the star, there are some spaces before it. Okay, so what we have to do? We have to print the spaces first, then only we can reach here and print the star. So which means how many rows are here? We'll just do it like So first row, second, third, and fourth row. And similarly, the columns. Okay, so that's the column numbers and the row numbers. Now what it is? Now we have to see, like in the first row, like what happens for the column 1, column 2, and column 3. We have to print. Okay, Saddam, I'll come to that again. So we will print the spaces. Okay. After printing the spaces only, we have to print the stars. So according to this one, we will do the recreation of the pattern. Okay. So it's better I create a matrix like this. Okay. Now, so we have to read the n value. I'll consider the n value as 4. That's what we have considered here. So I'll go with the same. N value as 4. Now what it is, I is there. I represents the row, J represents the column, and that two loops are there for the column. So I value is there. I value initially that is from 1. Okay, so when for the row 1, okay, like J value is there. So J has to go from 1 to n minus 1. So n minus I. Okay, 1 to n minus I. So n is 4, 4 minus 1, 3. Okay, so J is going from 1 to 3. Okay, n minus I is 4 minus 1, 3. So initially, so I'll keep that here. So initially, the J value, so J will be nothing but 1 when the J value is 1. Okay, then what it is, when the J value is 1, we have to print the space. Okay, the I value, row value is 1 and the column value is 1, we are printing the space. So the control comes here, printing the space. Okay, done. Now what it is, control is in the next one, okay, next space. So again what it is, this I has to sorry, j value has to increase for 1, or j value will become 1, j value will become 2, then 3. For all these things it has to print the space. So j value will, so this much is done, okay. After that what it is, this will complete, then only it will come here. This loop will complete it, then only it will come here. So one is get for the column value 1, it's printing the space coming here. Then what it is, j value will be incremented to 2. Again that is nothing but printing the space. So coming here, printing the space, that's also done. Again next one is also like j value 3, they're also printing the space. So for 3 also printing the space. Then what it is, the control comes here. So then after that, it can run only 3 times. That is as per the condition for the loop. Okay, after that, it's like the condition fails, it will come out of the loop. Okay, so now what it is, it comes here, then there is a k loop. So k is with respect to the column again. So 1 to I. So k will go from 1 to I value. What is the I value right now? That is nothing but 1. So 1 to 1, which means it's going to run only one time. Okay. So now the k is 1. It is going to run only for one time. So it is going to print the star. Where the control is now here. It will go to the next one. Okay. So after printing the space here, okay, it's right now in the column 4. There it's going to print the star. Done. After that, what we are doing? We are printing the new line. So the control comes to the new line here. Okay. Now again we will see. So after printing the new line, we are coming here again to increase the I value. I value will become 2 now. Okay. And the j value will become, or till where the j loop will run, 1 to n minus I. So 4 minus 2. So 1 to 2, this is going to run, and the k is going to run from 1 to I. Okay, I value is 2, so it's going to run from 1 to 2. Now j will get the value 1 first. Okay, so for the j value 1, it's going to print the space. So space is printed. Now again the j value will be incremented. J value will become 2. Okay, for that also it's going to print the space. J loop is going always printing the space. So again printing the space only. Okay, printing the space. Now what it is, the k, so that is done. 2 times it's done. 1 to 2, that is done. Now the control comes here, k loop. So it's going from 1 to 2. So k value will become 1. So printing the star with a space. That's what we are printing. Star is one character, space is another character. Okay, so the printing a star with the space is done. Again, what it is, the k value will be incremented to 2. Okay, so again, it is going to print a star with a space. Okay, so that much is done. After that, what we are doing, we are printing the new line. So the control comes here. Okay, then again, it's similar. So again what it is, I value will be incremented, I value will become 3, j value will be from 1 to n minus I. Okay, so again j is from 1 to n minus I. Okay, 4 minus 3, that is 1 to 1 only. Okay, k is from 1 to I. Okay, k is from 1 to 3. Okay, now we'll see j will get the value 1. Okay, so here control is here now. J will get the value 1, which means this loop is going to run only once. It's printing the space. Okay, now what it is, that is done. It can run only one time. Now the control comes here. So 1 to 3. So k will get the value 1 first. It's going to print the star and a space. Okay, so right now here, so it's going to print the star and a space. Okay, then the k value will become 2. Again, it's going to print a star and a space. So printing the star and printing the space. Then again the k value will become 3. It's going to print the star and the space. Star and the space. Okay, like this it goes on till where? Till the I value is full. That's the last one. So are you getting the pattern printed? Is that clear now? So one more row is there. Is this clear? Okay, whoever asked, is that clear for you? Okay. Now Saddam, so similarly we can do this as well. So 4, 4. Star with the space, yes. Else we won't get it printed. Okay, Ranjan. Okay, so here what it is. Like initially the count value. So we have a variable here, one extra variable just to print these values. Okay, for the printing purpose of the values, we are keeping that initializing that as 1. Why? Because we are starting from 1. Okay. Now what it is, so we have to read the n value. I'll read that as 4. Okay, for example, if that input given by the user is 4, then we will see. So I for row. Okay, I from where to where it's running. I from 1 to n. So which means it's going from 1 to 4. And the j initially the j, okay, j also from 1 to I only. So j is from 1 to I value. Okay, so we will see, like right now I'll go with the I value as 1. So I value is 1, so the loop will run for from 1 to 1 only, which means it's going to run only 1 times. Now what it is, we will come here, so control comes here for the first row, first column, and there what it is, I value, that is the row value, that is 1. Now j value, j will get the value as 1 only. Okay, so j will get the value as 1. It's going to run only 1 time. Okay, so what we are going to do there, when the j loop is running, we are going to print the count. We are going to print the count. Count is nothing but, right now the count value is 1. We are printing it 1. Okay, after that what we are doing, count value will be incremented. So this will become 1 plus 1, 2. And we are printing the new line. So from here the control comes to the next line. Okay, next line. Now what it is, again coming back here. The loop means always it will come back and check whether it has reached the limit or not, which means the condition is satisfied or not. If the condition is satisfied, it will go or keep on running. Okay, always all the loops, like I told yesterday, I have shown the while loop. Similarly, always all the loops will work based on one condition. So here I can say the condition is like less than n, less than or equal to n, less than or equal to 4. That will be the condition. So I value, whether it's less than, equal to, or equal to, less than or equal to n, that will be the condition. So till there this is going to run. So now the I value is 2. This will be incremented. Now j is going to run from 1 to 2, so 2 times. Now we will see. So the control is here right now. Okay. Now for the j value as 1, it's going to print the count value. Right now the count value is 2, so it's going to print 2. Okay. After that, what it is? It's going to the next column. So the j value will be incremented. J loop is running for 2 times. Okay, so j value will be the next one. And there also, like you can see, that is the column 2. So there again, what it is, it's going to print the count value. So after printing the count, every time we are incrementing the count value. So after printing the 2, the count will become 3. Now that is going to get printed here, 3. Okay, so after printing this count value again, we are going to increment the count value. Okay, this one is going to happen. So 3 plus 1, it will become 4. So after increasing the count value, what happens? The number of times for the for j loop, which will run for 2 times only. So that is done. It will come out of the loop, coming here, printing the new line. So the control comes here now. Okay, new line is printed. Again, going back, doing the increment on I value will become 3 now. Okay, so the j will go from 1 to 3. Okay, 3 times this j loop is running for the I value as 3. Now we will see the j value will become 1 first. Okay, so coming here, so I is done. J is starting with 1. So starting with 1, it's going to print the count value. Count value is 4 now. After that, incrementing the count, it will become 5. After that, again, what it is, going back and incrementing the j value. So j value will become 2. And coming here, printing the count value is 5 now. It's going to print 5. After that, incrementing the count value, so it will become 6. After that, again going and increasing the I value. It will run for 3 times. So j value will become 3 now. And then printing the count value. So now it will print the 6 and then incrementing the count value. It will become 7. Okay. After that, what it is, again going back and does the increment, but the condition there fails. Okay, j should be less than I value. I value is 3. So 4 less than 3 or not, the condition fails. Okay, so it will come out of the loop. It prints the new line. So the control comes here. Okay, like that it goes on till where? For the last row also. Okay, so till the I value become 4 or becomes n, it's going to repeat. Is that clear now, Sadam? Is it clear for everyone? So like this, whenever you work with the patterns and whenever you write the pseudocode, you have to try like this, whether it's printing in the same manner or not. You have to, this is in fact known as the dry run. Okay, dry run in the sense we are not doing any programming here. We are just seeing whether our logic is working properly or not. Okay, so this is what you have to do with all your programs or whenever you get a problem. Before writing the actual program, you have to do the dry run, okay, whether it's working or not. So that is the right way of checking. Okay, that in that case you can avoid getting the errors. Okay, a lot, it will help a lot. So fine. So we have seen a lot of patterns. We can try in the similar manner. Okay. So work on the classworks that's given as well. So now we will start with the next chapter. So this one is done. So now we'll start with the next one. That is nothing but introduction. So in introduction, what we are going to see the little bit of history from where it's coming, where it is used, and all these things we will see here. Okay, then only to the basics. So like it's like, have you ever thought how deep this C programming is? So maybe you have a little idea like how the C programming is, or at least you might be knowing the printf scanf and all. So even if you don't know, don't worry, you'll learn it. So the thing is like, even if there is some little idea, we are going to see that in a very deep manner. So how much ever we study this C, we are not going to finish up the study. And we have always a lot to learn more in C programming. So it's like a very vast topic. So whatever we are going to see here is nothing but what are the um, things that we have to, or the very important things, okay, very important basic things, as well as some advanced topics. How can we even go with the internal things, work with it, okay, all those things that we are going to see here. So where it is used, okay, so why we should learn it for a reason, isn't it? So where it is used in the sense, first one itself, system software development. So now my question is, do you know what is system software? Any idea? By listening to the term system software, okay, yeah, that is the operating system. Okay, so OS, and my question is now, what is an OS? What is an operating system? System software in the sense that's the operating system, I agree. Example is operating system itself. Yeah. Software, correct. Independent operating system, okay. Which communicate with the hardware. Okay, good. Interface software and hardware. Okay, correct. So you have an idea, like interface between software and hardware. Yeah, it enables the multitasking, multi-user and all. So software, system software in the sense like it can be the OS like Windows or Unix, okay, Linux or the Mac, iOS. Okay, many softwares or operating systems are there. What the operating system mainly does is nothing but fairly manage the system hardware resources are managed, okay. So as per the software requirements, like every applications, that's again a program written. So every, as per the requirements of the application, the hardware is managed in a very good manner, proper manner, without having any clash, okay. So in a very efficient manner, that is managed by the operating system. So this software development, so in fact, that is like what? Interfacing the hardware and software, it's a very difficult task. Okay, so the software system software development is a very difficult task. So if I ask the Linux operating system, do you know in which language it's written? Linux kernel, in which language it's written? It's written in CLE. Okay, so that's one example. Okay, so the system software application or the system software development, not the application, system software development, that's the one use of C programming for the development. So mainly it's used for the development purpose. Okay. Then the embedded software development. So what's an embedded software? Is there something, a separate category as embedded software? So there is no another category of operating systems like embedded software. Okay, so when an operating system is used for an embedded system, that is nothing but the embedded software. So we can do some customizations there, like whatever we need for a general purpose system. So my question is like, do you know what is the embedded system? Application based coding, correct? So embedded system and general purpose system. Embedded system in the sense what it is. Also called as software for specific test. Oh, yes, correct. Hard combination of software and hardware. Even if I say the laptop is also like our it's for a like it's again a combination of hardware and software. It's not an embedded system. It's a general purpose system. Okay, general purpose system in the sense we are going to use it for multiple purposes. Okay, like I can do the calculation. Okay, calculator can be used. The gaming, for the gaming purpose, I can use it. I can play the video, play the audio. Then what it is for the programming, I can do it. Okay, I can use it for multiple things, multiple tasks. So it's not only meant for do like one specific task. So the laptop or the systems that we generally use, that's a general purpose system. Embedded system in the sense it can do only one task. So it's created so that it, or designed so that it is meant to perform one task, one specific task. That is the embedded system. So that is one application. Okay, application level. So embedded system there, the operating system, whatever we upload there, we can customize it as per the requirement of that particular embedded system. So that's why it's called as the embedded software development. So we are just customizing the existing one. The generic one is not needed there. Okay, we can reduce a lot of space if we customize the operating system also. So that's why embedded software. So for the embedded systems, again, we can develop or we can customize the operating system as per the requirement. So that is the embedded software development. Again, a lot of things will come to the picture if I say, like, for example, which is the scheduling algorithm to be used. That depends on the embedded software, like embedded system for which this software is being developed. Okay, so whether it's like a robotic thing, a real-time application. So if it's so, it should the scheduling algorithm cannot be something like the general purpose one. So whatever I use for the laptop, even if there is a microseconds or nanoseconds of delay, that's fine, isn't it? We can bear with it. But what about the applications like robotics? Even microseconds or nanoseconds are of much importance. Okay, we can't neglect that. So in that case, the scheduling algorithm used is uh, a very like it's the priority based scheduling algorithm used. So like that, what are the things needed for the operating system that we can decide as per the requirement of the embedded system, that application that we develop. So again, that's a difficult task. It's not a one easy thing. So embedded software development. Okay, there is another application of the C programming. Then the OS kernel development. OS kernel is the main one. Like OS operating system is a, I will say that's a package of softwares. So operating system. So in that, generally when we speak the operating system, what we meant in fact is nothing but the kernel itself. Okay, kernel is the core of the operating system which controls, or I told the main purpose of operating system is to act as an interface between the hardware and the user applications. Okay, the hardware resources and the user applications. So, and what it is, this kernel is the one who in fact manages everything. Okay, for example, if like if an application needs to use the screen or the keyboard, okay, every time the application has to request the kernel only. Okay, no one else is the final decision with respect to the allocation of one device or even the memory, everything with respect to the system, everything, every hardware, whether it has to be given or not, allocated or not, for a specific process in the sense something which is being executed as a part of the program. So I told every application is a program written. So whichever programs are running, it will be requesting for some devices, and these devices, whether it has to be given or not, okay, that will be decided by the kernel. So again, the kernel is one who in fact manages the entire entire system. Kernel manages user application or OS. Kernel, without the kernel, there is no operating system. Understand, it's like a package. OS is, I can say OS is a package in that we say the CPU is the brain of computer, we say, isn't it? Like that, okay, I will say the kernel is heart of operating system. Without that, there is no operating system. Okay, kernel is one very bigger program which has millions of lines which is going to control the entire, or which is going to act as the interface between the hardware and the user application. Okay, that is one who manages. And rest of the things will come, like the memory manager will be there. So that is like the customization. A lot of things will come along with it, or the user interfaces. That's not a part of the kernel. The kernel is one which actually controls the hardware, the manages the hardware. Okay. So the rest of the things, again, so many supporting factors are there. For example, that's the user interface. To interact with the user interface, okay, that is nothing but the outer thing of the operating system. Okay, the outer, it's called as the shell. So that is where you usually call that as a shell. Okay, shell of the operating system. So it can be the graphical user interface, it can be the command line interface. Okay, any interfaces. So everything together, it's known as the OS as a package. Okay. So together, all the other applications, like some editors will be there. Okay. So some editors. So you are even using terminal, if you know the Linux. Okay. So something to edit and manage, the at least some command prompt is there. Okay. So that minimal applications which are even supporting to manage the entire system. Okay. That is together known as the OS. Kernel is nothing but the main program which controls the hardware. Okay, or is memory allocation done by kernel? Yes. Okay, the memory, whether it has to be allocated or not, that is the decision, or everything with respect to the hardware. Memory is also the hardware. Whether the memory has to be allocated, or if it's available. Okay, everything, the decision with the allocation of any hardware resource, that comes from the kernel. Okay, the final decision is from kernel. So that is the thing, the OS kernel. So I'm not going very deeply to all these things. So maybe you have studied it already, or you will be learning it in LI module. So you have to wait a little. So the thing is, like OS kernel development, this is one another important um, like application, or where it is used, where the C programming is used. Then coming to the next one, that is the firmware, middleware, and driver development. Okay. So what is firmware? Do you have any idea? Have you heard of it? Code inside a chip. Yeah. Okay, so it might be something like the, yes, BIOS or the startup codes to initialize the system. Okay, so it's not written anywhere else. So every system, like if I say the startup codes, or to initialize the system, the for the which helps for the booting. Okay, so it should be written in that particular system itself somewhere. Okay, so that is already written as a part of that hardware. Okay. So it's like it's a software which is written on a hardware component. Okay, maybe like so many techniques are there to do it. So again, I'm not going deeply to all those things. So many things are there to write onto the chip. Okay, so many techniques are there. So the firmware is nothing but a software which is already written on the hardware component. Okay, maybe usually that is nothing but the startup codes. So which has to work with the OS internally. Yes, firmware is also a program, is customizable every time as per the requirement. So the firmware that will be decided at the time of designing the system, that particular application. Okay, so later on you can't modify it. Once the system is designed, once that chip is ready, you can't modify it further. That's all. In the beginning, you can decide it. Yeah, it cannot be replaced. It's written on hardware using some techniques. Okay, like writing directly to the chip. Okay. Okay, so that is the firmware. So again, this is a software that is getting written on hardware. Okay, how the writing, in the sense it's using so many techniques to write on. There are so many techniques to write onto the chip. Okay. So for that, you should again understand in deeply, like the different things like the CMOS and all, then writing to it. Okay, so understand this is done at the designing stage itself, designing stage of the, or the chip development stage itself. This software will get written to the hardware, okay, to the hardware component. Then middleware. Middleware is again the software. Do you know what it is? Hmm? So middleware in the sense it's again a software that helps to interact with the user application or which means the OS has to interact with the user application. If so, the middleware will act as the interface. Okay, so for example, in your phone, maybe the Android phone, okay, you are installing some new application. So how the OS will communicate with this new application? Okay, there comes the middleware as the interface. So it will enable the communication of this new application with the software or the operating system that will be enabled by the middleware. Okay, connecting these two softwares, connecting the OS with the new application, both are software. That connection is done through the middleware. Okay, detecting the new application or making the communication with to the OS that will be done by the middleware. Okay. Driver, I'm coming to that point. So driver, do you have any idea difference between middleware and OS kernel? OS kernel is, see, middleware is like a piece of software which enables the communication between a new application and and the operating system. Operating system, within the operating system only the kernel will be. So middleware is out of the operating system, not a part of the OS. OS kernel is something else. Okay, so middleware is to handle the software. Okay, OS is to handle the hardware resources. Middleware is to handle or connecting one software with the other. One software which is not a part of the system, that's something new. Okay, so that is going to get connected with the OS by the middleware. When you are making embedded product, so Firmware, firmware code I told, it's usually what is there stored inside as the firmware. That is nothing but the startup codes to initialize your system. See, when it's the booting in the sense from the moment, like when you switch on your, for example, when you switch on your system, the laptop, the moment itself, are you getting the desktop? No, right? So from the moment you switch on, like one or the other process will be running in your system. Why it's running? One or the other process, or I can say that is the one or the other programs are going or running in the background. So when you switch on your system, you might be seeing some logos, something is coming and going. Then at the end, when the system is ready, then only you are getting the desktop. So till that, whatever is going on, that is nothing but the booting. Okay. So to enable the booting, there will be a booting sequence. So to know, for every system, there will be a booting sequence which is already designed. Okay. So which means it has to initialize the file system, and their file system should be up, and even the kernel will be up in between the booting sequence, not initially. Okay, to initialize all these things, some other software, piece of software is required to wake up all these things. Okay, so that is in fact known as the startup codes. So usually these codes are written on to that particular system itself. Okay, so in that system might be in a small memory, it will be already written. Okay, on that chip itself. Okay, so that is the firmware. It's not a part of the OS. It's OS in the sense the kernel is nothing but the main program inside the operating system. Even that has to be it has to be initialized by some other program. Okay, so there comes the importance of firmware, which is already there inside the hardware itself. Did you get it? Okay, once it's written, why I told when at the time of system design itself, that will be written to the hardware. We cannot change it. It's written to the chip directly, so we cannot change it at all. Middleware is between application and OS, or it's between the newly installed application. Okay, so just to enable the communication between the new application and the operating system, not between the hardware and the user application. Okay, Hari? If that is the communication between the hardware and user application, that is the OS itself. The OS is the interface between user application and the hardware. And the communication between the new application, the software installed. So it's like software to software communication. One side there is a new application, other software is nothing but the OS. Okay, so this software to software communication is enabled by another software, that is the middleware. Okay, is the confusion over? Is this much clear for you? Hmm? Yes or no? Any other doubt? Okay. So the driver development. So do you know what is driver? Device driver. Have you heard of it? Hardware device communication to OS through driver. Link between hardware device and OS. Okay. Okay. So the thing is like, for example, if you have it syncs the speed audio driver. Yeah. So it's like one, for example, if there is a printer, okay, you are connecting that printer to your system. So what happens? Will it directly ready for printing? So what is required? Your system should detect it first, isn't it? So the system should recognize the newly connected device, the printer, or maybe you will see this again when you connect the pen drive for the first time. Only for the first time you will see it. Okay, in case of printer or any new device connecting to your system, only for the first time you will see something like configuring. Okay, so nowadays it's very fast, it won't take much time. You will see something like configuring. So configuring what it in fact happens there. Have you ever seen what is in fact happening there? In fact, your system will be trying to recognize that particular new device which is being connected. It's trying to make the communication with the system. So that some supporting software should be there. Example of middleware, I can't specifically say. I told what it is. Apart from that, I can't give any name for the middleware. Okay, so that is with respect to the in every system it will be there. Middlewares will be there to handle the new applications. So if any software comes external, so external in the sense already when the OS is installed. For example, when any OS is installed, there will be a set of minimal applications will be there. Some editor will be there. Some minimal applications will be there in your system. Apart from that, whatever you download and install, that is completely the third party packages. So it's called the third party packages. There's something which is new is downloaded and installed. Okay, so that is coming from the outer side, isn't it? Outside the package it's coming. So what it is, to enable the communication between that particular new software and the existing operating system, this middleware is used in every system. So whenever you download and install any application, so if the OS has to manage, so again the new application will request for example, if you want to open that application. So one example, you have installed a new music player. Okay, you have installed one new music player. So in that, or something like a 3D painting tool. Okay, you done that. If you want to open it, then the screen should be used. Okay, the keyboard should be used. Then the memory should be used. To load and run every application, the memory is used. Okay, so what it is, to use that particular application, you have to, or that particular application has to take the help of operating system. So it has to communicate with the operating system, and it has to request for the allocation of all these hardware resources to the kernel. Okay, then only the kernel will be like communication with the kernel should happen. Then only the kernel will see whether that particular hardware is available and can be given or not. Okay. So that is, if that communication with the kernel, if that has to happen, what it is, that communication should happen first. These two, the new application should be enabled to communicate with the OS. That is done by the middleware. It's a piece of software connecting this new application with the OS. That's all. Okay, like that, when that is an external device, like a printer or a pen drive is nothing but a storage media, externally connected. So all these things should be recognized by the operating system again. Your system should recognize it, then it should communicate with the device. So in that case also, what it is, every device will be having its own input types, or a set of inputs required, or the set of outputs required, in what way it requires the inputs, what way it requires the outputs, and all. A set of things are there. Okay. So all these things need to be communicated with the operating system properly. Then only the operating system can communicate back with the device. So that is done using the device driver. So the device driver in fact enables the communication of the operating system with the externally connected, or not only externally, even the internal devices, whatever is there on the motherboard. Everything is nothing but one device. So if it has to communicate with the operating system, like the operating system should recognize that device first. Okay, so there should be a supporting device driver to do it. Okay, so 80% of the operating system contains the device drivers. Okay, is that clear? So did you get an idea what is firmware, middleware, device driver, and for these three software development, again the C programming can be used. Is this much clear? Yes or no? While we connect device driver, see, device driver is used for the devices, middleware is used for the softwares. Device is hardware, there comes the device driver, and the software, the external applications, okay, there comes the middleware. Okay, so middleware is not used again for the device driver. It's an equivalent for the device. Okay, when it's the software, the middleware will be enabling the communication. When it's an hardware getting connected, which is new to the system, the device driver is enabling the communication. Clear, Vaishnavi? Okay. Then again, the file system development. So in case of Windows OS, we have the driver system. Like usually that is like C drive, D drive and all. Okay. So like that, when it comes to the Linux system, that is like file system. Okay. I didn't get you, Sada. Okay, fine. Well, so the file system, whether that is the Windows or whether that is the Linux, so whether that is the driver system or the file system, this term with respect to the Linux only, file system. Okay, so the even in Windows nowadays it's used the file system. Okay, so that is nothing but the system files. Okay, so that can be again developed using, or many like OS has its own files to manage. Okay, so all these can be developed using the C programming again. Okay, so is this much clear? So which means, yes, especially what I meant here is nothing but the arrangement of the file system. Okay, that development can be done by the so file system stores and organizes the data and can be thought of a type of index for all the data contained in storage devices. Type of index. Hmm, yeah, file system, like again that depends on which OS it is. Okay, if that is if the latest Linux system, like everything is well organized. That is nothing but a directory structure. Directory in the sense that's a folder. So it's well organized. Every type of file will be in one directories. Okay, so devices can include hard drives. Yes, everything. hard drives, everything like every kind of like all the kind of memory storage media. Okay, the storage medias, that is again hardware. Okay, so the devices and storage media, there is a difference. But again, the device drivers are there required. Okay, to communicate with that particular storage media also, like I told in case of pen drive. So file system development in the sense the organization of entire file system. Okay, that might be the user files. User files is a very minute thing there. The rest all is nothing but for the working of the operating system only. Okay, so that is the entire file system and many more. C C programming. It's not scripting. Okay, C programming. Why it's called a C programming? I'll tell you. Okay, there is a difference between programming and scripting. So these are the applications and some of the applications where the C programming is used. Now it's a communication technique. So we know that's a programming language. So what this language means usually? So usually language, every language, even the English language, okay, that's a medium of communication, isn't it? So that's the same here. The C program or the programming languages, again, we are communicating with the system. It does not depend on, it's not specifically for any application or domain. It's a generic one here. Yes, Angit. So, any other questions? Well, so every language, like if I say the English language has its own set of rules to follow, isn't it? So that set of rules to, like how can you frame the sentences? For everything, there is something known as the grammar. The grammar is nothing but the rules to be followed when you handle the English language. So that is there in every language. In every language, there will be a set of rules to manage the language. So similarly, even the C programming has a set of rules to handle the programming language. Like this is the way you have to communicate with the system. Okay, that is what this set of rules says. That is in fact known as the syntax and semantics. Okay, the syntax is nothing but whether the proper method or proper rules are followed or not. Semantics in the sense the logic will be checked. Okay, whether the proper logic up to a limit, okay, up to a limit, the logic will be checked by this programming language itself. So when it is checked and all, I'll tell you. So this also like equivalent to the grammar, we have syntax and semantics. So understand that's like set of rules to follow in C programming. Okay, then again when we come to the English, like there will be something like the verbs, adverbs, nouns, prepositions, etc. Isn't it? So it's like some reserved words. Okay, so the nouns or adverbs, verbs, they are nothing but some reserved words. Okay, so like that, in C programming, we have the equivalents, a set of words called the keywords. So keywords in the sense, they are reserved words. Okay, they are meant for some specific purpose. So these words cannot be used as the variable names. That's the one thing that we have to remember. The keywords, there are 32 keywords in C programming. These 32 keywords we cannot use as, or it's meant for one purpose, we can use it only for that purpose. Yeah, default names. We cannot change it and we cannot use these names as the variable names also. Okay. Then we will see like which are the 32 keywords. We will see that. Then from where actually, like brief history also is here, like where actually C program start, okay, like where from when it was or when it was established. So in the sense, in 1960, okay, like a man called Al Gore, he created or he is known as the father of programming language, Al Gore. Al Gore created the first language that is he named it as Al Gore itself. Okay, algol. So that is in 1960 the algol was created. Okay, and then the major concept behind the algol was to introduce a structured language. Okay, well organized or the structured language. That was the aim behind this algol or creation of this algol. But the thing is like sorry. But the thing is like it was not or it was not for the like how we do the programming today like that nothing can be done using that particular language. Okay, so one structured language is created. Apart from that, okay, nothing else could be done with the algo. Okay, so basically that is used for the academic purposes and all, just to know this is how the structured language will be. That's all. Then later on, then in 1967, the BCPL was came into the picture. Okay, BCPL is nothing but the Basic Combined Programming Language. Okay, so the Basic Combined Programming Language. So in fact, again, that came from the CPL. Okay, so BCPL is a modified version of the CPL. CPL came in between and a never implemented language. Okay, you can see that it's a never implemented language. Combined programming language, it's known as the CPL. So from that, some more improvisations are done to it by the Martin Richard, and he tried to implement the BCPL. Okay, so modified version of CPL. Then what it is, a little more improvements done for it by the Ken Thompson, and then it was like from the BCPL, the B was emerged. Okay, that was happening in 1970. So the B language came to the picture in 1970. That is the advanced version of BCPL. Okay. Then what happened? So all these languages from the algol to the CPL to the BCPL and then to the B till the language B, what was the problem in the sense? All these languages were for one particular domain. Okay, it was only for one particular domain. They were not portable. That was the problem. So they struggled, or these languages again. It was insufficient to access the underlying hardware. Okay, so to communicate with the hardware, that was again a failure with the till the B language. Okay, then what happened in the sense the from the B language, the Denison Ritchie. Okay, Denison Ritchie is the father of C programming. So he actually what he done, he did some more improvements to the B language, and in fact we can say created the language, or we can say that is like development of the language. Okay, so B is improved and that is named the C, the next version. Okay, so that is named the C, and why it is created in the sense that's mainly to rewrite the Unix operating system. Okay, that was the main aim behind creating this language. Okay, the C program was emerged as a part of this rewriting Unix operating system. Unix operating system had to be improved. Okay, so it was created for a purpose. Okay, so to overcome the drawbacks of all the other programming languages, the C was emerged. So that the basic idea was to design a high-level programming language. Okay, high-level programming language, again, which can be converted to the low level when required, which means also efficient in accessing the underlying hardware when required. So basically it is created as a high level language, but this should even access the underlying hardware if required. So like that only the C programming was designed. Okay, so they wanted to even create a portable one. That was also happened. Okay, so this is made for like a purpose that is nothing but development of this Unix operating system. Now, this C contains the features of all the other existing languages, like from the Algol, then CPL, it's like never implemented, so we can even ignore that. Whatever is there in CPL, that is there in BCPL also. That's the improved version. So, Algol, BCPL, B, and then all these features of the Features of all these languages were there in the C language too, and much more. Okay, so it was a very powerful language designed for the development of this Unix. Okay, then what happened in the sense when the Unix started being using widely, like Unix, everyone started using it widely. Okay, so even by using or when the Unix is developed, the C programming also became famous, or the use of C programming became widespread. Elaborate the Unix. Unix is an acronym. We can't expand it. Unix, Linux, all these are acronyms. Okay, so uh, like there is no expansion for it. Okay. So the thing is like again what it is when the Unix was widespreadly used, even the C program, the people started to use the C programming also. Okay, in a widespread manner. So when the C came into the existence, it was the easier one. Okay, it was easier, it was portable, efficient, okay, compared to all the other languages. Linux is from Unix. Okay, Linux is another operating system which created like the Unix. There is a lot of reasons for that. I don't want to go to the history of Linux also. So if you're interested, you can check like Linux is created like Unix. Okay, Unix was already existing that time. Unix was the like it is a very old one. It was already existing that time, and it's a paid software. Okay, like that was the reason. In fact, the Linux came into the picture. So that's why even all the Unix commands will work in Linux also. Linux is from Unix. Okay, well, so the Unix was in force that time. Okay, so the Windows was not there. The Unix was the commonly used one. So, so what it is when the C was designed or when the C came into existence, it was easy, portable, efficient in accessing the underlying hardware compared to all the other programming languages that time. Okay, so then again, what happened? The Denison Ritchie, like Denison Ritchie, like they wanted to write the book. Okay, they write this book in the sense this book had many ambiguous like when the people started using it in a widespread manner, even they wanted to tell them like how to use the C programming in an efficient way. Okay, but the problem was like this book had many ambiguous concepts in it, which means which causes the confusion. Okay, so it had many such concepts which causes the confusion. To solve this confusion, there were none other than the writers. Like you can see, the Brian and the Denison Ritchie. They were the authors of this book. So apart from them, the creators of the C programming. Okay, the Denison Ritchie is the one man who is behind the development of the C. So apart from these people, they or a few are there, one or two are there who knows how the C programming can be handled with. Okay, so what they did is like they again they cleared some of the ambiguous concepts. Okay, cleared the confusions, and they wanted more experts in C programming to solve the doubts in it. Okay, so they again wrote and spreaded this book worldwide. Okay, so that everyone who uses the C can use it. Okay, so still it had many confusions. It was not completely clear. It was not the perfect solution for the or the proper management for the C programming. It was not the solution. Okay, so this continued for many years. Okay, this like based on the book to handle the C programming. So anyways, that was an efficient language, but again, there is something to refer, there is something to handle it, isn't it? So that was the failure part. The book was not a perfect one. So this continued for years, and later in 1989, okay, 1989, the ANSI in the sense American National Standard Institute. Okay, they did the standardization on the C programming. Okay, they did the standardization on C programming. Okay, so the like what happened in the sense they are like so many what exactly the ambiguous concepts were removed. Okay, the whatever concepts were causing the confusion, that was removed. A few more concepts were added. Okay, and the new standard was named as ANSYS. Okay, so that was actually done. The whatever caused the confusion, that was removed. Some more concepts were added, and it was named as ANSYS, or the standardization done by the ANSI. So from then it's known as the ANSI. Okay, so that is the standardization. Then after the first standardization, then around after some 10 years. Okay, so 89 was in 89 the first standardization was done. And after 10 years or many years, like around some 1999, like the new standardization, and they were named as the C9X standardization, the improvements. Okay, X stands for 3, 6, and 9. Okay, so these came into the picture or came into existence after 10 years of the first standardization. But the thing was like these standardizations didn't have much improvements from the actual standardization which was done. So even some companies follow the standardization for some projects and all. Okay, that is the limited use, but what we follow is nothing but ANSYS itself. So this standardization later on, as this had no much improvements from the already existing ones, they were actually removed. Okay, the improvements done, it was actually removed, and what we are using today is nothing but the ANSYS standardization. Okay, still the ANSYS
I'm not.
standardization is what we are following. Okay, is this much clear for you? Any doubt till here? So that's a part of the history. So then comes the important characteristics. So we know that it's considered as the middle level language. I have already explained that in the very first class. Okay, what is the middle level language? Why it is called as the middle level language at all? So it can be easily converted to the high level and the low level. So it contains the features of both. That's why it's known as the middle level language. So can be considered as a pragmatic language. Okay. So before going with that one, the middle level language. So one more reason why that is known as the middle level language. So that is something with respect to the abstraction level. Okay, it's known as the abstraction level. So what is this abstraction in the sense? Like, um, for example, printf is a very common function. Okay, so printf, if you want to print, for example, if you want to print hello, okay, we can just give the hello in it. Okay, and slash and forward printing the new line. Okay, so this is how we usually print something on the screen using the C programming, and this printf is the already existing function. Everyone might have used this at least once. Okay, so understand this is a very common, very commonly used function in C programming, which is already there, or this is a built-in function. Okay, everyone uses it, but nobody like, do you know what exactly or how, what is the function, what is actually the program behind this printer? How it's printing the hello? Do you know? Hmm? Do you know how it is actually going to print the hello? Any idea? So when we are giving the hello, it's in fact printing hello on the screen. But how it's happening, we don't have any idea. We are just using it as per the usage. Okay, that's what we know. We are not bothered how actually this printf and the program behind the printf, how it is working. We are not bothered. Okay, that is in fact the abstraction. Okay, so abstraction in the sense like the function is called this is a predefined function or an inbuilt function. The function is called, okay, or written in a program. Okay, that what is behind this particular function we don't know. That is hidden. Okay, the actual program behind this printf function we don't know. That is hidden, and that is in fact known as the abstraction. So if I say the abstraction level is high in my program, that actually means I have used a lot of built-in functions. Okay, I have just called the functions which are already there. Okay, so in that case, if my program contains many built-in functions, then the abstraction level is high. So if I'm using many built-in functions, then that is a high-level language. Okay, that is a high level language. So if a high level language, like if we are writing the high level language, we will be using a lot of functions. Okay, so that is why or that is a way in which one or the C programming can be converted to the high level language. In high level, the abstraction level is high. Okay, high level language. Okay, abstraction is high. Okay, why? Because we are going to use a lot of predefined or the inbuilt functions. Then when comes to the low level language where we are going to interact with the system. So I told there the instruction sets are used. Okay, so low level language there we are not going to use the built-in functions. It will be very rarely used. Okay, why? Because we are going to implement that everything in our own way or using the instruction set. Okay, so use of predefined functions are very less. We are going with the instruction set, and in that case, the abstraction level is low. Okay, it will be low. And when it comes to the middle level language, okay, middle level language will use a very like a good number of the predefined functions, inbuilt functions. So in that case, that is the abstraction level is medium. Okay. So this is how the abstraction level is different for the different programming languages. So it depends on how or how many predefined functions are we using. Okay, so again what it is, how much ever predefined functions we use or how much ever functions we use and call that in our program, that in fact like make some delay. Okay, so why the delay until you will understand later. So that's why the high level language comparatively low level language is faster than high level language. Why? Because here there it doesn't have to go for some definitions and all, it doesn't have to go in search of the if that is printf, the system has to go in search of the program behind the printf. Okay, and then accordingly it has to work. Okay, like that it doesn't happen for the low level language. It will be faster, like directly it's going to be understandable by the machine. Okay, did you get the difference? Yes or no? So this is one very important point that you should understand when why it's again called as the middle level language. Why? Because the abstraction is also medium in case of middle level language. Okay, is this clear? Yes or no? Abstraction, what is abstraction? Is that clear for you? Later on again we will see the abstraction. Okay. So in C program I have already told conversion from level to low level. Okay, the C program can be converted to middle level to low level by using the concept of pointers. Okay, we can convert it to the low level to interact with the system hardware. Even the memory is hardware. Okay, so we are going to use the concept of pointers. That's a simple example where we are converting the C program to interact with the hardware. Okay, that's one thing. Then conversion of C program to high level, we can add many functions in our program. So the abstraction will be high, so it will be converted as a high level language. Okay, that is the conversion of middle level to high level language. Okay, so that's the thing with respect to the middle level language. Then the next one is pragmatic language. So C can be considered as a pragmatic language. What is meant by pragmatic in the sense? Practical language. Whatever logic we have in or whatever ideas we have, okay, we can easily implement that using the C programming in a very efficient manner. So that is what the pragmatic language means. Then, uh, okay, used by advanced programmers and all. Okay, so it's widely used. Okay, so that's what it's meant. So whatever, it's widely used everywhere. Okay, so from the top level to the least level, which means top level in the sense for the kernel development as well as for any software development, the C programming is very widely used. Okay, so that is, and importance to the compact code, the modular code, that is very important when it comes to the C programming. I told with the minimum number of lines with the maximum efficiency. We are not compromising on efficiency, but we are compromising, like we have to write it in a very uh, neat manner, okay, with proper spacing and with the correct, like it is not a strictly evaluated or strictly the syntax and all the spacing and all won't be strictly checked. Okay, so even if some spaces are not there in some cases for the keywords and all, after that the space is needed. Apart from that, if you give some spaces, extra spaces, or if you miss some spaces, it won't end up in the error. So it's not common for every programming languages. Like, guys, can you please turn off the light? Okay, so it's not something very common. Like in some programming languages, that is not like that. It's like hmm, it's like it will be strictly evaluated. Even the spacing matters. Okay, so that will happen in other programming languages like Python, if you know. Okay, so in C programming, the spacing is not mandatory, but it should be given for the neat presentation. Okay, so that is very important for understanding the program by someone else. Okay, so even like maybe today you are writing the program. Okay, after some 6 months, if you want to understand the program, then it should be very clearly written. So that is important. The compact code is very important. The modular or compactness is nothing but with the minimum number of lines. So abstraction level doesn't matters in case of converting middle level language to low level. Abstraction level is important there. Okay, we will reduce the number of functions as minimal. Pointers, I'm not telling the every time whenever the pointers need to be used, we have to use some function. It's not like that. Okay, that pointers concept is it's like accessing the memory. Okay, so there the functions are not coming to the picture. So if you want to convert the C to the low level, then we are keeping the usage of functions as minimal. Okay, which means the predefined functions will be reduced to the max. Then only we can say the abstraction level is less. Pointers are required for low level conversion. What is actually the pointers? Pointers are going to, or with the pointers, we are going to access the memory. Memory is the hardware. To interact with the hardware, that is a low level language. Okay. So it can be for a specific purpose also, like the general purpose as well as specific purpose also, we can use the C program. Like you can even write a simple program, you can even write any, for the OS development also, you can use the C program. Okay, so that's what it is from top level to the least level. Then this is what I told, free formatted language, not strongly typed. Okay, not strongly typed. Then efficiency and portability are the most important consideration. Like high efficiency codes can be created, even high efficient binaries can be created using the C. And the portability, like it can be, like suppose if you are writing a low level program, okay, with respect to one system, like you are writing it for the Intel, okay, then later on you are going to take the same program to the some other architecture. So I told always writing the low level or the assembly codes or the startup codes, that depends on the architecture. Okay. So what it is, suppose if you are doing it using or what it is, the C programming is used for such things, such programs are created using C program. Then if you are taking that to another system, okay, like it can be any program which is going to interact with the hardware. So if you are taking to another system or another architecture, this C is flexible to some extent. You don't have to change the entire code. Maybe with respect to the ports and all, you have to update it. You have to make some modifications so that you can use the same code in the new architecture as well. Okay, for the same logic, you can do some changes. The C is flexible for some extent. So medium flexibility is there. So you can change or modify it and then you can use it in the new architecture. But that is not possible if that is completely written, like the low level language is completely written using the instruction set. That is not possible. So that is why the C program is widely used. It's highly portable. Okay, so low level coding can be done using the C program, and that is why, because it's portable. Okay. Then library, it has its own library, okay, which with all the definitions of the inbuilt functions. It's a very vast one. So these are the important characteristics of the C programming. Do you have any questions? Any questions here? Okay. So I told the keyword. Keyword is like a reserved word meant for some specific purpose. So we have 32 keywords I told. So we will quickly see which are the 32 keywords. So there is spacing is required. Okay, proper spacing is required for the understanding of the program. I told today maybe you are writing the program. After 6 months, if you want to understand it, it should be properly written. Or if someone else is going to check your program, it should be properly written. But when you do the program like it's by the compiler, it's not going to be strictly evaluated whether the proper spacing is done or not, apart from some specific cases, like with the along with the keyword without space you can't continue the next thing. Okay, if you do that, like without the space after the keywords, if you continue with the next word, then the compiler will give you the error. Like that, the spacing is required but not strictly checked. That's all. Keyword and token. Keyword is nothing but specific tokens, in the sense the separate words only. Okay, not like it has a specific word, specific purpose. Okay, keyword in the sense reserved word. Okay, reserved word means that can be used only for some specific purpose. So there is something called as the data type. For example, if I want to store an integer, I should have a variable of the type integer. Okay, for that I should create a variable using this int keyword. Okay, like that, it has a specific purpose. So data types, how can we do it and all, we will see later. As of now, understand for the data types, there are 4 different keywords used: char, int, float, double. Okay. Then there is something called as the modifiers and qualifiers. So there also we use signed, unsigned, short, long. That is to modify these data types. Then the qualifiers are there. That is like constant, volatile. So where the qualifiers are applied and all, we'll see later. Then for the loops, we know for is a loop, while and do while. So do is also used as the keyword. Then for the jumping, okay, jumping statements are there. So that is go to, break, continue. These words are also used for some specific purpose. Then for the decision making, we have if, else, then switch, then case, then default. Okay. So within the case, the default is used like that. These words are also used only with some meaning, specific meaning. Then there is something called as the storage class. Okay, why the storage class? What it is, we will see. So different types of storage classes are there, or in which all ways we can store the data. So auto, register, static, extra. Okay, that is again one another chapter. Then derived in the sense we are going to create our own data types. So user defined data types. Okay, struct unions, enums, and type defs are there. Apart from this, there are some keywords like void, return, and size of. Okay, like this we have in total 32 keywords in C programming. Okay, so we have to see that one by one. We are going to learn all these one by one in different chapters. So overall, this is how the C programming looks like. Okay, documentation. In the sense, we are going to write the header, like what is this program about, or if some kind of documentation, maybe your name, author's name, okay, something like that, or a little briefing about the programming. Everything can be given here. Documentation. So documentation, usually the documentation will be commented. Okay, so if that is a single line commenting, you can go with double forward slash. Okay, that is for single line. Okay, one line. Then multiple line commenting, in the sense you have to start with the forward slash and the star. Okay, then the comments. Okay, the documentation should be done multiple line. And where is the end of the commenting? There you have to give star and a forward slash. Okay, that is for the multiple line. Okay, that is star in. So this is the way in which this is the format in which you have to do the commenting. Okay, then so that comes here. After that, preprocessor statement. As of now, you don't know what is preprocessing and all. So it's like some header file inclusion and all happens here. Header file name will be included here. Okay, then if some global, there is something called as the global variables or something like macros. Okay, all those things which has to be not inside any functions. Okay, so this out of the functions, that space is called the global space. Okay, out of all the functions, that space is actually called the global space. So any variable or any function can be here. Okay, anything can be declared here. Void main, no, main is actually a function. Okay, so I'll come to that. So then comes the main code. Main code in the sense that is the main function. Okay, so yes, that is in out, like we can't say that is out in the global space and all. So global space actually is meant for like out of the functions. Main itself is a function. Okay, so why the main? In the sense, the main is the function, or from where actually the program execution starts. Okay, so always we have to have at least, yeah, and the entry point for the execution. Always we have we should have the main function in our program. That too only once. Okay, so it will have so many local variables, so many program statements. Okay, then the function calls, so many things are there. So if you are doing some function calls, if not predefined the one, then the function definition should be here. Okay, function definition also should be here in your program. So somewhat like this. So this is the commenting documentation file header. Okay. Then we are including the stdio.h. So for all our programs, we are going to include this particular header file. What it contains, in the sense, it's going to support all the predefined functions like the printf, scanf, which means all the input output functions. Standard input output functions will be supported with this particular header file. Okay, so if you have to use the something like this printf, okay, one predefined function. Okay, that is an output function. We are going to get it as an output, isn't it? So that is the output function. So we have to use this header file. So to get the support of on the predefined functions, we have to use one or the other header. Not only this, many header files we will use one after the other when as the class goes on, like in progress. Okay, so that we will see one after the other. Then this is the main function. So usually we will give here int only. Okay, that's for a reason. I'll come to that point. So void main, if you knows if you have a little knowledge on the C program, you might be thinking, why can't I use the void here? Okay, so that's in fact for a reason. I'll come to this point when we come to the functions chapter. So as of now, what we are going to use is only int main. Okay, so main function, we can't name this as anything else. Why? Because we are going to compile all our programs using the compiler. Okay, and then only we will get the executable file. So when we execute, always again the compiler will be checking for the main only. Okay, so the program execution starts from the main always. So this main is important, and whatever is given inside the main, that is going to get executed. And this is also for a reason. We will come to that. As of now, understand, when there is a return 0 given for the main function, that is the termination point of the program. Okay, return 0 in the sense the control moves out of the function or coming out of the function. If that is the main function from which the control moves out, then that actually means that is the program termination. Okay, so this is the overview of the program. Then later on, we will see how actually you can, how actually we can write the program. Okay, so everything given here is for a reason. Like I told, the int is given, the return is given. So to understand this, you have to wait a little. Okay, so we have to even know which are the types of functions and all. Okay, so now how can we compile? So we are going with the GCC compiler. Okay, GCC is used, and again with respect to the execution, like if that is in that is in the uh, terminal, okay, or the WSL if you have, or if you have something like the Visual Studio, that is also fine. Okay, so GCC, okay, GCC is the compiler that we are going to use. So what is this GCC in the sense? Yeah, you can use any any application for it. Okay, the only thing is it should be supporting the GCC. So GCC, so that is GNU's compiler collection. Okay, so GNU's compiler collection. So how can we, like, if that is in like in Linux? Okay, if you are using Linux, how can we do it in the sense GCC? Then the file wherever we do the program, they usually store that using the .c extension. So whatever is the file name with the .c extension, okay, that is given to the compiler. GCC space the file name .c. So why we are going with this particular compiling in the sense. So somebody asked me whether this is a programming or scripting. So do you know what is the main difference between the program and the script? So programming in the sense, program cannot get executed directly. So if you try to execute a .c file, you will get the error printed on the screen. Why? Because the machine is unable to understand the program that we have written. Okay. So that's why we are taking the help of the compiler to compile it, and finally as an output what we get here is nothing but an executable file. And usually by default that executable file will be named as a.out. Okay, so this is only executable file, but in case of scripting, that file itself is executable one. For example, if that is the bash scripting or the Python scripting and all, if you do the dot slash or if that is in Linux, if you go with the execution of that file using one method, then you will get to see the output directly without going with the compiler. That is understandable by the machine and it will directly getting executed. Okay, so that is like line by line execution happening there when that is the interpreter. So there is something called as the interpreter to interpret the whatever program or the script that you have written. But in case of C programming, this program, so usually programs will be compiled and the scripts will be interpreted. So this program, it's not understandable by the machine. So we are giving it to the compiler to generate one output file. Okay, by default, the output file is named a.out. Suppose using GCC, if you want to create an output file, okay, with a specific name. Okay, so then you have to go with the -o as the option to create the output file. And suppose it's like output dot out. Dot out is the extension of the output file. Okay, then you will get the output file in this particular name. Okay, so that's also possible. So this is how usually we will go with the compiling. Why the compiling? We have to get a executable file to see the to get the output. Okay, that's why we are going with the GCC compiler and getting the output file. So this is understandable by the machine. Only this will be understandable by the machine. Okay, a lot of things are there from the .c file to the .out file that we will learn in detail later. Okay, as of now, understand this is the reason behind it. Why the compiling? There is a reason for it. Okay, so that's all regarding the C and the basic programs and all. So we will see that later. Okay, the programming part and all we will see a bit later. Before that, we have to see the actual basics. Okay, so do you have any questions apart from the int main, void main, and or why the return? You can just keep it aside as of now. That we will see later, understands later. So apart from that, do you have any doubt? How to install GCC in Ubuntu? If you are going with the Ubuntu, you can just try whether it's already there by doing okay GCC minus version. Okay, if it's not there, okay, what you can do in the sense sudo. First, you have to go with the command sudo apt-get update. Okay, update it so that all the packages will be ready for the installation. Okay, after that you can do sudo install GCC. Okay, this can be done if you are using the WSL or for the WSL or for the Ubuntu users. Okay, so this much for the updation. At the next command line, the sudo apt install GCC, that is for the installation of GCC package. So you can just avoid getting errors for the GCC package installation if you go with the update first. Okay. So any questions till here? Is that clear for everyone? We'll wind up the session. It's already